Well, I didn't write down the. There we go.
And 3.
Hey everyone, welcome to our lesson on the compound interest formula. This is a really cool formula, really good for many fields. It's helpful for figuring out amounts of money that sits and grows over time at a certain rate. Really neat to work with. In taking a look at this formula, we need to know what each piece represents so that when we go to fill in our information, we know where to put that. So let's take a look. A of t, that is going to be our final amount once we've calculated out all the other variables. The p here represents our starting amount, initial amount that we're putting in or depositing. The r up here at the top is our rate of growth. The n on the bottom of this fraction is our compounding period, and you'll notice there's two of those. The n is in two locations. It needs to go there and up as the power to join with t, which represents time, the amount of time that is passing over the course of whatever we're discussing. The compounding period is something that's difficult to get used to sometimes. It is how many times that it's going to be compounded per year. So don't get that confused with actual time as in years that are passing. So, for example, you may come across wording in your problem that says that this is going to be compounded annually, so that's once a year. You would put in a 1 for both of those n locations. You might see monthly, 12 times a year. Weekly, there's 52 weeks in a year, so I would put a 52 there. So just be on the lookout for wording that says compounded a certain amount of times. Now, if you see the words compounded continuously in your problem, you're actually going to use a whole separate formula with a base of e. We're going to take a look at that now. Often referred to as the PERT formula. Similar to the formula we just looked at, some things match up. For instance, the first a of t is still going to represent the final amount. The p is still going to represent the initial amount that you start with. But here we're going to use this base of e, which is just a special number in math, sort of like pi. E is approximately equal to 2.718. The r here is our rate, once again, and the t is our time that has passed. So we'll be on the lookout for those words compounded continuously for when to use that formula. Alright, so we're going to use a real example here and take a look at how the compound interest formula works and how much money is growing over a certain amount of time. So suppose we have an amount of $1,500 that we want to deposit into an account, and we know that that account has a rate of 3.4%, the interest rate, and we see the words here compounded quarterly. So remember, that's going to be our n. Quarterly, that is 4 times a year, so we're going to use an n of 4. And we want to know the balance after 6 years. So that is going to be our t. So don't get our n and our t confused. When you're looking over a problem like this, it's helpful to highlight or underline those important pieces of what you're going to fill into the formula. And then it's also a really good idea to just go ahead and rewrite the general formula. So we saw the words compounded quarterly, so that means we're going to use our regular compound interest formula. A of t equals p times 1 plus over n raised to the n times t. And now we're going to fill in our information from our actual problem. So final amount will equal, our initial deposit is $1,500, so that's going to go here for p. 1 plus, our rate is 3.4%, but I want to mention here that when it's presented to you as a percent, you need to move your decimal spot over 2 spaces to the left so that you can put in the decimal version of that percent to work with your calculations. So I'm going to move that over. It's actually going to be 0.034. That's what I'm going to insert in for calculations. Over my n of 4, that n also is present up as part of the power, and then 6 years for t. So we're all set up now. Now we have to be really careful with order of operations. We just want to do things in the correct order. So I recommend starting with the power, then moving to the group inside parentheses, and then multiplying by 1500. You're sort of going backwards here, the way it's set up. When you do that, we will arrive at around $1,837.86 approximately. So in real life, if we had this amount to deposit at this particular rate, we can let it sit for 6 years, we would end up with a little more than what we started with. It's growing. It's a growth formula. So we have more than what we started with. And you want to look and make sure that your answer logically makes sense. We ended with more, and that is good because this is a growth formula. If you end up with less, something may have happened in your calculations. All right, let's take a look at the same example with the same information, except that this time we have compounded continuously present in our example. So remember, we're going to switch over to that other formula, the P e to the RT formula. So let's rewrite that. Amount equals P e to the RT. And we're going to look at our pieces and insert our information again. So final amount, what will it be this time? We're going to put in our $1,500 deposit for initial, the P spot. Multiply that by E, which was approximately 2.718, raised to the rate of 0.034 again, times T of 6 years. So we'll start with the powers. We will raise our E to that power in our calculator. Continue and multiply by 1,500. And this time we're going to arrive at a slightly different amount because we used a slightly different formula. $1,839 this time. Alright, so it's as simple as that. We're just putting our information into the formula and calculating it using the correct order of operations. So let's review. We need to know when we're dealing with these types of problems when to use which particular formula. So remember, you're actually going to see the wording compounded continuously if you need to be using that other formula, the P with the base of E to the RT. And one common mistake that we see lots of times is that people confuse that N and that T. Just remember, T is going to be your actual time that's passing, the actual time that you're letting the money sit in that account. And then N is the compounding period, the amount of times that it's being compounded per year. So just remember the difference between those two, and that N has actually 2 locations it needs to go in that original formula. So this is going to conclude our lesson on the compound interest formula.